Coastal shorelines are the backbone of the economy and livelihood of the island communities. What contributes to the susceptibility of the shorelines that are sensitive to the climate change? Our paper is here to identify the most exposed areas from critical physical parameters that affect the vulnerability of the shorelines in order to prioritize adaptation measures. The study provides insights into the vulnerability of the Hawaii's coastal areas using a GIS-based coastal vulnerability index method to assess the relative influence of biophysical variables to identify the most hazardous locations. The study area covers the shorelines of the 7 main Hawaiian Islands, which have unique coastal ecosystems susceptible to the climate change. Although the average exposure index of the islands are at the low to medium vulnerability level, one-third of the state has moderate to high vulnerability. Maui, Oahu, and Kauai are the top 3 most vulnerable islands. The biophysical parameter effects are significantly different among the islands. The observed probability distributions of the exposure and erosion indices for the islands are also provided to help to guide the planners in estimating expected distribution for future scenario modeling. Identifying and assessing highly vulnerable areas, as well as the contributing factors to the vulnerability, are necessary groundwork in developing a strategy for surviving coastal disasters. A better understanding of the vulnerability of the shorelines from coastal stressors leads to improved climate change adaptation plans. The first goal of the study is to identify which environmental parameters most affect Hawaiian Islands and understand the linkages between them. The second goal is to reduce uncertainty when prioritizing of vulnerable coastal systems and determine the effective linkages between the vulnerability assessment and development planning. And the third goal is to show what factors reduce the resilience in specific regions through inspection of the input values affecting exposure and vulnerability, which addresses the most critical underlying factors affecting the vulnerability. We use Coastal Vulnerability Index method to measure the exposure and sensitivity and understand the adaptive capacity of the shoreline segment. An open source GIS-based program developed by the Natural Capital Project called Integrated Valuation of the Ecosystem Services and Trade-offs, or INVEST, is used. This overlapping analysis of the INVEST model is used to understand the interaction and contribution of the input variables. The research presents the histograms and probability distribution using a curve-fitting methods for both input variables and exposure indices. The results focuses on the input vulnerability metric distributions and exposure indices to demonstrate the potential susceptibility of the shoreline to climatic stressors. The results include the followings. One-third of all shoreline segments are exposed to the climatic stressors. Sea level rise, geomorphology, and natural habitat input indices indicate a broader range spread. Among all the input vulnerability metrics, geomorphology and wave exposure most affect the coastal exposure in the Hawaiian Islands and is a dominant factor for Kauai and Oahu. High wave environments dominate in all islands, and having Big Island of Hawaii and Maui show the strong influences from the sea level rise. The most dominant effect of the surge exposure is also observed in Maui. Due to their rocky coastal cliffs, Kaho'olawe and Hawaii have the more refractory effects for wave action and sea level rise. The islands show an average to low to moderate vulnerability. The most vulnerable islands found in Maui, Kauai, and Oahu. The natural habitat role in coastal exposure is greatest on Lanai and Molokai. Maui and Kaho'olawe have the highest average of the erosion indices, while Oahu is less prone to the measurable erosion due to the existence of its coastal defense structures. Although the islands show in ranks of moderate vulnerability, the most vulnerable shorelines reaches the measure of the high exposure risk values. The work resulted in creation of a visual representation of coastal vulnerability for input variables and exposure indices. An example of a general coastal exposure maps of the islands can be seen. The goal is to use these distributions to identify areas that are priorities for immediate action points. The contributing factors can be used as a tool for increasing the public awareness and supporting planning, design, engineering, and implementation of hazard mitigation and climate change adaptation efforts. Future work including multiple dynamically interacting physical and social factors in a comprehensive multi-risk assessment that collaborate interdisciplinary expertise would improve the assessment of the vulnerability. A local scale vulnerability assessment can be developed to identify crucial needs and design appropriate adaptation solutions. The research displays a good initial picture of what is the exposure of the shoreline of the Hawaiian Islands and can be applied to the other coastal communities. For more in-depth information, please check the article. The dataset of this research is publicly available. Thank you for listening.